From now on in this course, we are going to take a huge step forward in our understanding of how objects move. In case you didn't realize it, until now in this course, I was treating everything as a point particle. So for example, if a box was moving from here to there, I was treating the box as a point particle. If I threw you off a building, I was going to treat you as a point particle. If some cow is running, I was treating the cow as a point particle, and so on and so forth, okay? So everything I was treating as a point particle, but of course realistic objects, nothing around you is a point particle. In no object around you is the whole mass of the object concentrated at a single point. None. Every single realistic object is not a point particle. And now we are going to study the motion of objects by treating them as actual objects, not simply as point particles. Okay, so we are going to take our first stumbling steps along this journey today. Okay, so for example, this thing, if I throw it, this thing is not just going to move in a parabolic trajectory. It's also going to rotate and wiggle and wobble as it moves through the air. There you go. Okay. The lamest demonstration of all time, okay. And you can do this and whatever, okay. So khair ye pagalon ki tarah karte raho, enough. Seriously, okay. Acha, enough with the sarcastic clapping, okay. So anyway, so realistic objects, this object wasn't moving as a point particle. It wasn't just a point particle. Of course, it has some dimensions, okay. It has some size. How can we treat the motion of these realistic objects? Now this object, now look at it closely again, okay. Ab gaur se dekhna. This object, while it moves, seems to be following some very complicated motion. It's wiggling and wobbling and so on as it moves. But there's a single point within this object, the single point associated with this object, more properly speaking, which seems to be moving along a simple parabolic trajectory. That point is known as the center of mass. Center of mass, let me just point it out loud and clear, is not a mass. पूरा कोर्स गुजर जाता है सेंटर ऑफ मास की डायमेंशंस लोग केजी लिख रहे होते हैं, ओके. सेंटर ऑफ मास इज अ पोजीशन. A position vector is known as a center of mass. The center of mass is actually mathematically equal to a position vector. And you'll see how exactly will we find that position vector out. You'll see that. But the center of mass is a position vector. It has dimensions of length. Okay? So the center of mass is not a mass in spite of its name. Okay? The center, the center of mass, जिसमें center है, that's the key word. Okay? That refers to a position. It's basically the average position of your mass. Mass of what? Well, we'll clarify that in due course. Okay? Right? So, for example, if you're dealing with a box, the center of mass is kind of the average position of all the atoms within the box. As this duster is moving, the center of mass of this duster is kind of the average position of all the atoms within this duster, and so on and so forth. How do you exactly calculate this average position? Again, you'll see that, okay? Okay? That's basically the key idea, okay? Anyway, so let's start. Not a big deal, okay? Anyway, so let's start with this, okay? So now the point is that you are treating not just a single point particle. The idea is that any realistic object is composed of billions and billions of point particles. So I want to now treat essentially collections of point particles. Okay? I want to treat billions and billions of point particles. To get started along that, because any realistic object is composed of billions and billions of atoms. 1 mole mein 10 raised to power 23 particles hote hain. That's the only thing that you remember from chemistry perhaps, okay. But anyway, okay, ab to apne s orbital aur p orbital bhi aapko yaad honge, okay. Why is that useful? Okay, you don't know, okay. But anyway, okay, लेकिन आपके लिए याद करना जरूरी है क्योंकि 2 नंबर आप उसी तरह हासिल कर सकते हो, okay. So anyway, so we are going to treat these collections of point particles. Okay. So for example, to begin with, of course, instead of straight away jumping to billions and billions and billions of point particles, let's treat a relatively simple situation. 3 particles. 2 particles तो कुछ ज़्यादा ही trivial हो जाता है as it turns out. 3 particles shows you the essential mathematics at play, and the case of 3 particles you can immediately generalize to billions and billions of particles. Essentially वही result naturally generalize हो जाता है. Okay, so let's consider 3 particles. So you have particle arrange in any way you like. They could be interacting with each other, they could not be interacting with each other, they could be tied to each other with some strings, so on and so forth. Okay, they could not be tied to some strings. This could be the Earth, this could be the Sun, this could be the Jupiter. Okay, whatever. Okay, but imagine that these are 3-point particles. Okay, just to begin with. So you have particle 1, particle 2, particle 3. You could label these as particles A, B, and C, of course, except that the English language has only 26 alphabets. You want to treat billions and billions of particles, so it's better to label particles by using numbers rather than alphabets. Okay, English language plus the Greek language will only supply you with only enough number of symbols. Okay, it won't go to billions and billions of particles. So anyway, okay, so what do? I want to treat the motion of these particles. Now the idea is that what I first of all do is that I identify my system of particles. So suppose you are interested in not just the motion of particle 1, but you are interested in the motion of particles 1 and 2. So I draw an imaginary boundary around particles 1 and 2. And I say whatever particles are there within this imaginary boundary, it's up to you to set up this boundary. Okay, this defines your system of particles. As in kind of I'm just saying that particle 1 and particle 2 are in my system of particles. It's up to you to define what you mean by your system of particles. You could have said that, okay, particle 1, particle 2 and particle 3 define my system of particles. That's a perfectly valid choice as well. Except that you usually define your system of particles as the bunch of particles whose motion you are interested in. So for example, if you are pushing a box, you define your system of particles as all the atoms that comprise the box. If you are throwing some object up in the air, you define your system as all the objects, all the atoms that comprise the object that you have thrown up in the air. If you have thrown your friend off the top of this building, the system is all the atoms that comprise your friend. Okay, okay, right? So in this case, suppose I am interested in the motion of particles 1 and 2. So I have defined my system of particles is particle 1 and particle 2. Okay. Then what do? I apply Newton's second law to particle 1. I apply Newton's second law to particle 2. I don't bother to apply to particle 3 because I'm not really interested in what happens to particle 3. But that's not to say, of course, that particle 3 has no effect. Particle 3, of course, in general will be exerting forces on particle 1 and particle 2. Okay. So first of all, I just write down using the things that I know. Okay. This is basically the same idea. The central idea that we are using today is basically the same thing that you do to calculate the area under a curve. You chop up the area into small pieces, analyze each piece, add it all up. Any realistic object, I am essentially going to chop it up into little pieces, aka point particles. I am going to see what happens to a single point particle, and then I am going to add it all up to see what happens to this bunch of point particles as a whole. Okay? That's the basic idea. It's basically the same. The central idea is the same, exactly the same as you do when you calculate the area under a curve. Okay. So Newton's second law applied to the first particle says that the total force acting on the first particle equals m1, the mass of particle 1, times the acceleration of particle 1, which for reasons that will become clear in due course, is preferable to write the acceleration as the double derivative of the position vector. Because in my manipulations I'm going to do very soon, I'll be using some properties of the derivative. So that's why I'm writing out the acceleration as a derivative. Okay. Of course, you could have written down m1, a1, that's fine. Now you see the beauty of using vectors. This is completely general. Don't need to worry about any direction and so on. All the directions are built into the vectors. Okay. Doing all these manipulations without vectors is a complete nightmare. Okay. But with vectors, is very straightforward. Okay. Similarly, I can do the same thing for particle 2. F2 is the total force acting on particle 2 equals. This is exactly analogous to how you find out the area under a curve. एरिया अंडर कर्व है आपके पास. लेट मी जस्ट रीकैप. आप कह रहे हो सर एरिया अंडर कर्व क्या चीज होती है, याद आया? यू चॉप दिस अप इनटू लिटिल पीसेस. ये देखो छोटा सा एक लिटिल पीस कंसीडर करते हो, उसको देखते हो इसको, इसका कितना एरिया है, इसको क्या हो रहा है, एंड देन यू एड इट ऑल अप. So, okay, so for imagine if you have a box, I've chopped it up into little pieces, I'm looking at 3 of those pieces. Okay, so then I'm looking at piece 1 and piece 2 over here right now. I'm looking at what happens to piece 1, what happens to piece 2. Or in general, what happens to an arbitrary piece I. Then I would write down Fi is equal to Mi double derivative of Ri. जिस तरह आप इस little piece का area लिखते हो, Yi times delta Xi. ओके ठीक है. नाउ व्हाट डू यू डू? आप कहते हो थोड़ा सा सोचते हो, राइट? दिस इज द मोस्ट डिफिकल्ट स्टेप. You have to think a little bit and you have to identify that okay what exactly is F1. I mean आप कहोगे सर मुझे क्या पता? You haven't really identified how the particles are interacting with each other. But I can write one thing. I can say that F1, whatever the force on particle 1 is, it has 2 possible sources. There's a force that's going to be exerted on particle 1 due to particle 2, and there's another force that is going to be exerted on particle 1 due to particle 3. That's it. Okay, whatever the physical origin of these forces, never mind. One of these forces or even both could be very, very small, could even be 0. Never mind. Okay, that you can set it to be 0 later on. What I can write definitively is that F1 I can write as F₁₂, this notation means force on particle 1 due to particle 2, okay, plus F₁₃, force on particle 1 due to. Similarly, I can write down F2 equals F₂₁ plus F₂₃. ओके, अब जब ये एरिया करते हो, जब टोटल एरिया कैलकुलेट करना होता है, क्या करते हो? एक जो क्षेत्र से पीस का एरिया है, you consider it and then you start adding up all the areas of the pieces. Similarly, अगर मैं इन दोनों इक्वेशंस को ऐड करूं तो आपको क्या नजर आ रहा है? Something magical takes place. आपका F₁₂ plus F₂₁ क्या होगा? 0. Why Newton's third law? You have just used Newton's second law until now, but now if you consider Newton's third law, F₁₂ will be the equal and opposite to F₂₁, as in F₂₁ equals minus F₁₂. Remember, these are vectors. So equal and opposite means that one of the vectors is the minus of the other vector. Okay, so when you will add these two equations, this will cancel this. What does that mean? If you go back to this diagram. Now you say, well, my system is comprised of particles 1 and 2. There are some internal forces in my system, there are some external forces. What do I mean by internal force? The internal forces are the forces that the particles within your system are exerting on each other. जो आपके intermolecular forces होती हैं और वो आपके intramolecular forces होती है, okay? The intramolecular forces are between the molecules. If you consider a molecule as your system, the intermolecular forces are external forces. Molecules एक दूसरे के ऊपर लगा रहे हैं. The intramolecular forces are the internal forces. Molecule के अंदर ही लग रही हैं. Similarly over here, अगर ये hydrogen atom है, the force between particles 1 and 2 are the internal forces. The force that this atom is exerting on this atom is an external force. ये आपके system से बाहर वाला particle जो है, system वाले particles पे force exert कर रहा है. That's what we mean by an external force. An external force is a force exerted on one of the particles within your system by a particle outside your system. Again, it's up to you to define what do you mean by your system. Okay, but once you have defined कि ये particle मेरा system है, stick to that. Okay, right? So, ये बताओ आप, ये internal force है, external force है? ये internal है, external है? चलो शुक्र है कुछ तो समझ आ गया. Okay, so until now, हाँ. और सफर करो मोमेंटम अगले लेक्चर में आएगा. हाँ एग्जैक्टली यस उसी तरह से आएगा. Okay. अच्छा okay. So now if you add these two equations, what do you get? You get that okay F₁₁ plus F₂ equals F₁₂ plus F₁₃ plus F₂₁ plus F₂₃ equals by Newton's cycle. Now F1 was equal to this, F2 was equal to this, and therefore I can write that this thing is also equal to m1 times the double derivative of r1 plus right? Okay. And then you see F₁₂ cancels F₂₁. And you're left with F₁₃ plus F₂₃ equals m1 double derivative of r1 plus m2 double derivative of r2. And this I can just say that this is the total external force acting on my system of particles. The external force on particle 1 plus the external force on particle 2. This is the total external force acting on my system of particles. So let's just label this as Fe. E denotes external and not 2.71. Okay. Just pointing that out because your imagination knows no limits. Okay. So this is 2.71. Not 2.71. This is E for external. Okay. So this equals then so far so good, very simple manipulations. Now somebody had the genius idea and that said that essentially the right hand side ko, why don't you write this as the total mass times the acceleration of some vector. The total mass over here being the total mass of the particles within your system. Why don't we write this right hand side into the form of capital M, where capital M is m1 plus m2 times the double derivative of some position vector. As in you are then writing down Newton's second law in the form of the total external force equals the total mass times some acceleration. Acceleration of what? Well, we need to explain that. Okay, we need to understand that. Okay. So the objective is that can you write this in the form of capital M times the double derivative of some position vector? The answer is that you can, and that's exactly what defines capital R. Capital R is your center of mass. Okay. अभी कर रहा हूँ इसी को शो करना है. अभी मैं से कह रहा हूँ can you do this, and now my objective is ताकि ये ना हो कि मैं डेरिवेशन करने बैठ जाऊं आपका ये सर जी ये क्या कर रहे हैं हम ओके हाँ किधर ओके ये मॉनिटर ने तो बड़ा तंग किया होता है अभी उसी को कर रहा हूं okay okay so now my objective is to essentially massage intellectual massage okay massage this into this form where capital M is just shorthand for m1 plus m2, aka the total mass of the particles in your system. ठीक है? Now how can you आप कहोगे सर कहाँ ये और कहाँ जो आपने लिखा था? Well, I need to put this equal to the total mass times the double derivative of capital R. So how do I get capital M over here? I mean, you take inspiration from what you used to do in grade 7, okay? जब आप मैथ्स का कोई प्रॉब्लम सॉल्व करते थे, you found some number, you flipped to the back of the book and you found that your answer was off by a factor of 2 or 3, and then you said, okay, I need more calculations, let me just multiply my answer by 2, and there you go, you've gotten the correct answer, okay? ज़बरदस्ती ले आओ capital M essentially. So let me just ज़बरदस्ती मैं लिख देता हूँ ये लो भाई capital M, okay? एंड देन आई राइट डाउन दैट ओके, अगर कैपिटल एम से मैंने किया तो फिर साथ में ऑफ कोर्स ग्रेड 7 वाला जुगाड़ नहीं करना, साथ मुझे डिवाइड भी करना पड़ेगा कैपिटल एम के साथ. सो आई एंड अप डूइंग नथिंग एंड देन द रेस्ट ऑफ द थिंग इज द होल थिंग इज देन बीइंग मल्टीप्लाइड बाय m1 times double derivative. So in other words, I've done something extremely stupid. All I've done is to multiply by capital M and divide by capital M. इसी चीज को मैंने essentially 1 से मल्टीप्लाई किया है, but 1 written in the form of capital M divided by capital M आ गया. So what I do then is to say कि भाई ये 1 over capital M को मैं इधर ले जाता हूं. So that this whole thing becomes just that. और अब मैं कह सकता हूं कि ये जो कर्ली ब्रैकेट्स में जो चीज है, कैन आई राइट दिस इन द फॉर्म ऑफ अ डबल डेरिवेटिव. कैपिटल एम तो मैं कहीं ना कहीं से ले आया हूं बाहर. कैन आई राइट द अदर थिंग इन टर्म्स ऑफ अ डबल डेरिवेटिव ऑफ समथिंग, which I can, and now the time has come to actually use the properties of the double derivative. इसलिए मैं double derivative लिखी जा रहा था. Okay, so you can write this whole thing as capital M times 1 over M, and now you see you can pull the derivative outside. Derivative of M1 और M2 change नहीं हो रहे. M1 और M2 constants हैं. The mass of the particles are not changing. So you can write the whole thing as, यानी उल्टा जा रहे हो आप. The derivative of 5 times y equals 5 times the derivative of y. Now you are going the opposite way. Okay, 5 times the derivative of y equals the derivative of 5 times y. Or in other words, the derivative, this double derivative can be written as the double derivative of m1 r1. And this thing can be written as the double derivative of m2 r2. In other words, इसको मैं लिख सकता हूं डबल डेरिवेटिव ऑफ m2 r2, और इसको मैं लिख सकता हूं एज द डबल डेरिवेटिव ऑफ m1 r1, एंड देन देयर इज अ प्लस साइन इन बिटवीन. अब मैं डबल डेरिवेटिव और भी बाहर लेके जा सकता हूं बाय यूजिंग द सम रूल ऑफ डिफरेंशिएशन. दिस द डेरिवेटिव ऑफ द सम इक्वल्स द सम ऑफ द डेरिवेटिव्स. नाउ आई एम गोइंग द अदर वे अराउंड. ये सम ऑफ द डेरिवेटिव्स है, इसका डेरिवेटिव प्लस इसका डेरिवेटिव. That's equal to the derivative of the sum. As in, I can write this whole thing in the square brackets as the double derivative of m1 r1 plus m2 r2. Okay, so I can write the whole thing as double derivative of m1 r1 plus m2 r2. There you go. I mean, आपको उसी वक्त नजर आ जाएगा कि आप इधर से इधर जाने की कोशिश करो, क्योंकि ये देखो ये डबल डेरिवेटिव बन जाएगा m1 r1 प्लस डबल डेरिवेटिव ऑफ m2 r2, एंड डबल डेरिवेटिव ऑफ m1 r1 इक्वल्स m1 टाइम्स द डबल डेरिवेटिव ऑफ r1. डबल डेरिवेटिव ऑफ दिस थिंग इक्वल्स m2 टाइम्स द डबल डेरिवेटिव ऑफ r2. दैट्स ऑब्वियसली दैट. एंड देन इसके बाद मैं क्या करूं, मैंने इस फॉर्म में लेके जाना है. देखो तकरीबन मैं आ गया हूं. डबल डेरिवेटिव तकरीबन सारे का सारा बाहर चला गया एक्सेप्ट कि वो पेस्की 1 over m है. उसको मैं क्या करूं, उसके अंदर डाल. ओके, सो यू बेसिकली गेट ये, और फिर ये आप कहो कि भाई इसका डबल डेरिवेटिव लो ना ये, बिकॉज 1 over capital M is also a constant. The whole technique works because m1 is a constant, m2 is a constant, capital M is then also, of course, also a constant. And therefore, the whole thing can be written as capital M times the double derivative of R, where capital R equals m1 r1 plus m2 r2 divided by capital M. हाँ जी
सर, इसमें तो कैपिटल एम कोई भी नंबर कांस्टेंट हो.
कौन सा? नहीं कैपिटल, yeah sure, but you want to write it in the form के capital M total mass हो सिस्टम का, because you want to write down Newton's second law for your system of particles. तो उसमें टोटल क्या आ जाएगा, अब F is equal to MA system of particles लिखना है चाहिए, तो M इधर क्या होना चाहिए, mass of your system of particles. That's right. Okay. Yeah, sure, mathematically you can use any number as long as कोई mass है कोई, but whether that's a useful thing or not, well, turns out that's not very useful. Okay. Okay, this is useful. Okay. अगर ये कैपिटल R को घूर के देखो, ये पहचाना कुछ कुछ तो देखा होगा, नहीं सेंटर में प्योरली मैथमेटिक्स टर्म्स में देखो, दिस इज बेसिक द एवरेज वैल्यू। अनफॉर्चुनेटली मुझे बताया गया कि स्टैटिस्टिक्स के ए लेवल्स में जो है स्टैटिस्टिक्स को बाय-ठुदा कर दिया गया है, सो अपेरेंटली पीपल नो नथिंग अबाउट स्टैटिस्टिक्स, ओके, दिस इज लिटरली द एवरेज वैल्यू। अगर मैं कहूं कि भाई प्रोबेबिलिटी के साथ एवरेज वैल्यू भी नहीं आपने निकाली, ओके, बट दिस इज काइंड ऑफ द एवरेज वैल्यू, जो बेसिक टेकिंग द पोजीशन वेक्टर ऑफ द फर्स्ट पार्टिकल मल्टीप्लाइंग विद द मास ऑफ द फर्स्ट पार्टिकल प्लस द पोजीशन वेक्टर ऑफ द सेकंड पार्टिकल मल्टीप्लाइंग विद द मास ऑफ द सेकंड पार्टिकल, और फिर आप डिवाइड करो टोटल मास से टू गेट द काइंड ऑफ द एवरेज वैल्यू, व्हाट्स द एवरेज पोजीशन वेक्टर ऑफ द टू पार्टिकल्स। बट आपने कहोगे सर वो r1 प्लस r2 डिवाइडेड बाई 2 नहीं होना चाहिए था, why isn't the position vector, average position vector r1 plus r2 divided by 2? Well, over here you are giving equal importance to both the particles. What this is doing is basically giving more importance to the particle with bigger mass. This is what is called a weighted average. जिस तरह पाकिस्तानी इलेक्शन होते हैं, some votes are more important than other votes, okay? Similarly over here, some masses are more important than other masses, okay? And you take that effect into account by multiplying the position vector by the mass, ताकि automatically जिस particle का ज़्यादा mass है, that has a bigger contribution towards capital R. इसलिए आपका अर्थ सन सिस्टम का सेंटर ऑफ मास बेसिकली सन के अंदर ही होगा, बिकॉज द सन इज सो मच बिगर देन द अर्थ। सन और अर्थ का जो सेंटर ऑफ मास है दरमियान में नहीं होना चाहिए, बिकॉज द सन इज सो मच बिगर देन द अर्थ। सन को हावी होना चाहिए इस कैलकुलेशन पे, एंड दैट्स एग्जैक्टली व्हाट यू गेट यूजिंग दैट। Okay, so that's why you are multiplying the position vectors by the masses, so that you can take into account that different particles will contribute differently towards the center of mass due to their masses. Their masses need not be the same. If their masses are the same, अगर दोनों पार्टिकल का एक ही mass होता फिर क्या आता आपका कैपिटल R? आपका लिखते हैं mR1 प्लस mR2 डिवाइडेड बाई 2m, और ये देखो mm काट जाता तो क्या आ गया R1 प्लस R2 डिवाइडेड बाई 2, जो आपकी यूजुअल एवरेज वैल्यू होती है। बट हियर ऑफ कोर्स बोथ पार्टिकल्स यू आर ट्रीटिंग इक्वली। जब मैं एवरेज वैल्यू इस क्लास का निकालता हूं मार्क्स की, आई ट्रीट एवरी स्टूडेंट इक्वली। इससे मैं सारे स्टूडेंट के मार्क्स ऐड करके डिवाइड बाय द नंबर ऑफ स्टूडेंट्स। बट ऐसे यू नो कि कोई पर्टिकुलर स्टूडेंट है मेरा बड़ा लाडला है, उसको मैं ज्यादा इंपॉर्टेंस देनी है, आई मल्टीप्लाई हिज मार्क्स बाय 3 इन कैलकुलेटिंग द एवरेज वैल्यू। ओके, नहीं ऐसा कोई भी नहीं है। ओके, अगर मैं लाडला बनाना भी चाहूँ, मैं कैसे लाडला बनाऊंगा? मुझे तो नाम भी नहीं याद होगा, सारे 400 लोगों के कैसे नाम याद होंगे? ओके, so this is the average value. Okay, of course this is the average value for only two particles. The next course of action that we need to take is to generalize this to bajillion particles, okay, bazillion particles, okay, billions and billions of particles. The mathematics seems more complicated, of course, but the basic technique is exactly the same. न्यूटन सेकंड लॉ, हर पार्टिकल के लिए न्यूटन सेकंड लॉ लिखोगे, सारी इक्वेशंस को ऐड करोगे, ऑल द इंटरनल फोर्सेस विल कैंसल, you just be left with the total external force. The total external force will equal to the mass times acceleration plus mass times acceleration plus mass times acceleration. You can massage that into total mass times the double derivative of some position vector. तो आप गैस करो कि जब ढेर सारे पार्टिकल्स होंगे तो कैपिटल आर क्या होगा? गैस करो। दो पार्टिकल्स के लिए वो है, तो ढेर सारे पार्टिकल्स के लिए क्या होगा? Exactly, which in the summation notation I will write as this. And capital N is my total number of particles, could be 10 raised to power 23, could be 10 raised to power 46, it doesn't matter. This is M1 R1 plus M2 R2 plus M3 R3 plus M4 R4 plus M5 R5. I have to stop, otherwise if I start doing this until 1 billion particles, आप भी बुढ़े हो जाओगे, मैं भी बुढ़ा हो जाऊंगा, and we'll get nowhere, okay? So anyway, हाँ, तो that is taken into account. उसके लिए पोजीशन, उसके सेंटर ऑफ मास की कैलकुलेशन ढेर सारी करेंगे, हैंग ऑन, बट ऑफ कोर्स बिफोर यू डू एनी कैलकुलेशन फिजिक्स इज वेरी इंपॉर्टेंट टू एटलीस्ट गेट अ फील फॉर के ये बता के रही है चीज आपको फिजिकली. ओके, सो इन अदर वर्ड्स दिस इज जस्ट टेलिंग यू काइंड ऑफ द एवरेज वैल्यू. It's kind of telling you the position around which the mass is evenly distributed. और वो मैं आपको बताऊंगा क्यों वो बता रही है. तो अगर डब्बे का सेंटर ऑफ मास किधर होगा, सिमेट्रिकल डब्बा है, slam bang in the middle of the box, because around the middle of the box all the mass of the box is evenly distributed. Okay, that's how practically you can very quickly find out the center of mass. Look for the point of symmetry essentially. Okay, anyway, so I'll show you that this is true. तो क्या करेंगे, आपके पास ढेर सारे पार्टिकल हैं, and you say, you know, ये कुछ particles हैं मेरा system है. Okay, need not be 4 particles, there can be many more. Of course, I have to you know stop drawing them. तो फिर क्या करोगे? You say, जिस तरह आप ये जो एरिया एंड कर्व करते थे, इसको किससे लेबल करते थे, इस छोटी से बार को? This is the arbitrary ith vertical slice. आप कहते थे इधर x की वैल्यू xi है, इधर फंक्शन की हाइट होती थी f of xi. For those of you who were attending the boot camp while half asleep, some of you may be remembering this, okay? For others of you, this is complete gibberish. Okay, क्योंकि आप busy थे party करने में, celebrating your BBC that you got in your A levels, okay, to barely come through. Okay, so you have this, okay, so this is, आप कहते थे the area of this vertical bar is f of xi times delta xi, और फिर add कर देते थे to find out the total area. याद आया? This is something very similar. I'll be doing something over here. I'll be using this sum notation over here as well. तो arbitrary, अपने system में कोई भी arbitrary ith particle मैंने लिया, उसके साथ मैं क्या कर सकता हूँ? I'll write down Newton's second law for the arbitrary ith particle. Fi equals mi. I could be any particle within my system. So for previous case, I could be 1, I could be 2. So this is not just a single equation, this stands for actually n equations. This is any one of those n equations. So पिछले केस के लिए, you know, you are getting F1 is equal to m1 times double derivative of R1. F2 equals double derivative of R2. So of course your eyes say that this is one equation, but your brain should say that this is n equations, okay? Post processing, okay? Okay, so anyway, so this actually stands for n equations and not just a single equation, because I could range from 1, 2, 3, 4, 5, 6 all the way to capital N. Capital N being the number of particles in your system. उसके बाद आपने क्या किया था? आपने ये सारी ऐड कर दिया था. You added up the left hand side over all the particles. लेकिन उसको करने से पहले आपने एक और काम किया था. You split up Fi into the total force acting on particle 1 previously into 2 parts, internal and external. The force acting on particle 1 due to the particle within the system, which was 2, and also the force acting on particle 1 due to the particle outside the system. Do the same thing over here. I can write down Fi as the total force acting on the particle I due to any particle outside. उसको मैं Fie कह देता हूँ. Fie is the total force acting on particle I due to all the particles outside my system. Plus, अब internal forces मैं कैसे लिखूँ? Of course, internal forces की form तो इस तरह होगी, Fij, where J is again from 1 to n. तो ये of course this will stand for F1, 2, F1, 3. अगर I 1 है, this will stand for F1, 2, F1, 3 and so on. लेकिन उनको add भी तो करना है. You want the total internal force. तो ये sum किसके ऊपर होगा? J के ऊपर या I के ऊपर? J के ऊपर नहीं, दोनों के ऊपर नहीं. I तो आप एक particular particle को देख रहे हो इधर. J is equal to 1 to n. With the understanding that जब J I के बराबर होता है तो क्या होता है? 0. A particle cannot exert a force on itself. देखो उसको पता है कि जब भी मैं क्वेश्चन पूछूं आधा टाइम 0 ही होता है आंसर, okay? तो 0 कह दिया, okay? क्यों? Okay, so particle cannot exert a force on itself. So what many people do is just to say कि भाई J is not equal to I, कि आप J को I के बराबर सेट ही नहीं कर सकते. Many people do consider J is equal to I, लेकिन वो फिर कहते हैं कि FII जो है वो जीरो है. It doesn't matter, of course. If you add zero to anything, that thing is not going to change. Okay? Right? So this is the total internal force. This is the total external force on your particle I. इसके बाद मैंने क्या किया था? अभी तक तो मैंने स्प्लिट सिर्फ किया है. इसके बाद ऐड भी तो किया था ओवर ऑल द पार्टिकल्स विद इन माई सिस्टम. वो याद है पिछली दफा मैंने F1 प्लस F2 किया था पिछली दफा. So that all the internal forces cancel out. तो फिर मैं किया था essentially ये काम किया था. If you have only two particles, of course you just have F1 plus F2 over here. This will be equal to, अगर ये ऐड करूं फिर मुझे ये भी ऐड करना पड़ेगा और ये भी ऐड करना पड़ेगा. ये ऐड करूंगा तो क्या आएगा? The total external force on all the particles within my system. अभी इधर सिर्फ एक पार्टिकल को देख रहा हूं, इधर अब सारे के सारे पार्टिकल्स को देख रहा हूं, इकट्ठे क्या हो रहा है. So you get I FIE plus you have I is equal to 1 to n. इधर भी लिख सकते हो आप I is equal to 1 to n if you want. And you have J equals 1 to n, but J is not equal to I of Fij. ये खूबसूरत सी चीज किसके बराबर है? देखा? अच्छा, अब क्यों जीरो है? नहीं, फोर्सेस है ना. आई मीन यू आर ट्रीटिंग द पार्टिकल्स एज डिस्क्रीट. इसको बाद में इंटीग्रल्स बनाते हैं, इसको नहीं, पर ये बाद में इंटीग्रल्स की फॉर्म में आए. अभी इंटीग्रल बनाने की जरूरत नहीं है. ओके ओके. सो यू हैव ओवर हियर, देखो अगर सपोज करो मैं लेता हूं सिस्टम में मेरे 4 पार्टिकल्स है, 1 2 3 4. What is this thing equal to? Suppose I am looking at the first particle, okay, and then of course I have to add it up over all the particles. What does this say? पहले I को 1 सेट करो, ठीक है, I को 1 सेट कर लेते हैं, तो मेरी पहली टर्म आ जाएगी 1. फिर मैं J को क्या सेट कर सकता हूँ? I को मैंने 1 सेट कर लिया, J को क्या सेट कर सकता हूँ? 2. I cannot set it equal to 1. That's what this thing means. उसके बाद क्या अगली टर्म क्या आएगी? I को भी 1 ही रखना है. अब J की अगली वैल्यू पे जाओ, 3, ओके, F1 3. फिर अगली टर्म 1 4. इसके बाद नाउ गो टू द नेक्स्ट वैल्यू ऑफ I. 4 ही पार्टिकल हैं अभी मेरे. नेक्स्ट गो टू द नेक्स्ट वैल्यू ऑफ I जो कि है 2. अब फिर J की पहली वैल्यू क्या होगी? 1. F2 तो हो नहीं सकता, F2 3 होगा, F2. फिर क्या करोगे? गो टू द नेक्स्ट वैल्यू ऑफ I. देखिए इसलिए मैं कहता हूं आधी नोटेशन इसलिए है क्योंकि वी आर लेजी पीपल. ओके, why bothering writing all these long lines of equations when you get by with this beautiful sigma symbol? Okay, so you have F31 plus F33 नहीं हो सकता, F34 होगा, प्लस F41 प्लस F42 प्लस. That's it. As in, for 4 particles, this thing is just shorthand for this huge thing. Okay? When you have these 2 sigma symbols appearing, पहले sigma symbol की value set करो, sum up over the second sum, then change the first index, sum again over the second sigma, and so on and so forth. Okay? अच्छा, अब इसके बारे में गौर से देखो. How is this 0? It always occurs in pairs. In actual fact, this is exactly what we mean by a force. जब आप किसी के साथ हाथ मिला रहे हो, ऑटोमेटिकली दूसरा बंदा आपके साथ भी हाथ मिला लेगा. If you have F12, you'll automatically have F21. You cannot have F12 in isolation. So F12 cancels out F21. F13 किधर है? F31 किधर है? हाँ, there you go. F3 है. F14 F41 किधर है? ये फिर है. F23 F32 किधर है? ये फिर है. F24 F42 किधर है? ये फिर है. F34. Okay, anyway. So the point is that this thing equals, and you're just left with this thing which I just write as the not. I mean, पूरी जिंदगी आपने 0 नहीं बना देनी. This is the total external force acting on your system of particles, which we just write as Fe simply. पिछले केस के अंदर ये था F₁₃ plus F₂₃, because that was the total external force on your system of two particles. 1 और 2 system था, 3 outside the system था. Okay, so this is the total external force. और ये एक इसके बराबर है. Well, अगर मैंने इसको एड अप किया था, फिर इसको भी तो एड अप करना है. अब वापस आओ, जंगल में गुम हो गए हो. So this is equal to sum over I is equal to 1 to n mi double derivative of this thing. क्या चीज? अभी वो 2 पार्टिकल्स के लिए किया था, अब मैं n पार्टिकल्स के लिए कह रहा हूं. वो मैंने गैस किया था, मैं शो कर रहा हूं कि वाकई उसके बराबर ही होगा. ओके, सो दिस इक्वल्स, अब कैपिटल M मैं कैसे लिखूं? कैपिटल M ओवर हियर इज नॉट m1 प्लस m2. कैपिटल M over here is the mass of all the particles within your system is equal to m1 plus m2 plus m3 plus m4 plus blah 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 all the way to mn. Okay, so defining your capital M to be capital M is the sum of all the masses. So again put it in, और आपका ये 1 over m, and then you have the double derivative of the sum mi. और फिर क्या करूंगा? वेल, डबल डेरिवेटिव को मैं बाहर लेके जा सकता हूं और सम से भी बाहर चला जाएगा डबल डेरिवेटिव. सो आई विल बी लेफ्ट विद दैट, और ये कैपिटल M को सम के अंदर ले आता हूं, एंड यू विल बी लेफ्ट विद डबल डेरिवेटिव ऑफ सम ओवर I is equal to 1 to n mi ri over कैपिटल M. और फिर कैपिटल R क्या है? नहीं, this thing in the curly brackets is your capital R. If you identify this as capital R, you have your final result. That the total external force on any system of particles equals the total mass of your system of particles times the double derivative of the center of mass of your system of particles. This does not look like much, but trust me, this is how we went to the moon, okay? आपकी जो रॉकेट के डायनेमिक्स सारे इसी से फॉलो होते हैं. आपके कोलिजन्स में क्या होगा, इसी से फॉलो होता है. कंजर्वेशन ऑफ लीनियर मोमेंटम इसी से ही आता है. आपकी जो भी इस कोर्स में फॉलोइंग चीज आनी है वो इधर से ही आनी है. दिस इज इन प्रैक्टिस द मोस्ट यूजफुल फॉर्म ऑफ न्यूटन सेकंड लॉ, बिकॉज दिस इज द फॉर्म ऑफ न्यूटन सेकंड लॉ दैट इज डीलिंग विद रियलिस्टिक ऑब्जेक्ट्स. करेंगे पूरा, उस पर एक लेक्चर होगा. ओके Okay, so you have that, where just to reiterate, the capital M is the total mass and capital R is the average position vector, is the center of mass. Okay, right? अच्छा जी, तो अब कहते हैं कि why do we call this the average position? This is essentially, now you need to get a feeling for the capital R है क्या. So the next 3 lectures are all about this stupid equation. Okay, ये एक equation के बारे में तीन lectures हैं, the following 3 lectures. We'll get started today, of course, but the first thing that you need to understand is कि capital R exactly है क्या. The capital R, of course, has been defined mathematically like this. Okay, it's kind of the average position vector of your particles. And now, by looking at capital R in different contexts, we can then start to kind of understand what capital R is physically. Okay, so that's the basic idea now. Okay, Yes, we can accept it's not that simple. वो उसकी तरफ आएंगे. ओके, हाँ, उसकी तरफ आएंगे. ओके, दैट्स अ वेरी गुड क्वेश्चन, बट इट्स नॉट दैट सिंपल. ओके, दो सेंटर ऑफ मास के दरमियान आप न्यूटन्स लॉ ऑफ ग्रेविटेशन नहीं लगा सकते, एज इट टर्न्स आउट. ओके, अच्छा, okay. So why am I calling the average position? The first hint for you to find out the center of mass is that it kind of refers to the average position, which means that essentially the position about which the mass of your object, if you're looking to find out the center of mass of an object, this is the position about which the mass of the object is uniformly distributed. So for example, दो तीन नंबर मैं आपको देता हूं, इसके एवरेज वैल्यू क्या आएंगे? Thank you. I mean, that took a disturbingly long amount of time to calculate, but otherwise, yes, it is 2, okay? अच्छा, अब 2 का मैं डिफरेंस निकालता हूँ 1 से. What is the difference of each data point? आप डेटा साइंस और मशीन लर्निंग करने चले और ये डेटा डिस्ट्रीब्यूशन आपसे नहीं हैंडल हो रही. Yeah, so you calculate the difference of each data point from the average value being 2. So 1 minus 2 is minus 1. 1 minus 2 मैंने किया, ओके? डेटा पॉइंट माइनस एवरेज वैल्यू मैंने कहा था. इधर इससे क्या आएगी? 0, और इससे क्या आएगी? अगर इन तीनों को ऐड करूं, what do you get? That's actually always true. कोई भी आपका डेटा सेट है, you calculate the difference of each data point from the average value, add it all up, you are guaranteed to get 0. In that sense, the average value lies slam bang in the middle of your data set. In exactly the same way, your center of mass lies slam bang in the middle of a uniformly distributed object. जितना mass left पे है उतना ही right पे है, जितना ऊपर है उतना ही नीचे है, जितना आगे है उतना ही पीछे है. It has to be evenly distributed, just like 2 is evenly distributed over here. तो एक और थोड़ी सी नॉन ट्रिवियल एग्जांपल कर लेते हैं. इसका एवरेज वैल्यू क्या आती है? 1, 2, 3, 10, 2.5, yes, okay. 1 minus 2.5 क्या आता है? Add it all up, क्या आएगा? It's guaranteed. आप प्रूव कर सकते हो that the difference of each data point from the average value, add it all up, you will get 0 for sure. Yeah, it's a 2-line mathematical proof, okay. So in that sense, you know, कहते हैं सर मीडियन नहीं होता दरमियान में डाटा पॉइंट का. Yes, if you arrange your data in some order, the middle point will be the median. But in this sense, the middle data point is something different. It's the point of symmetry essentially. किस point के गिर्द जो है आपका data is kind of distributed evenly. कि जितनी negative values आएंगी difference की, उतनी positive values आएंगी difference की. Okay? Right. So now suppose मैं आपको कहता हूं कि एक rectangular sheet है. इसका center of mass कितना है? किधर है? Center of mass किधर है? Uniform rectangular. So the first question you ask, sir, ये uniform भी है. ये तो नहीं है कि ऊपर वाला half lead का है और नीचे वाला half लकड़ी का है. Then of course it's not symmetrical. The top half is not the same as the bottom half. In that case, अगर मैं कहूँ कि top half lead का है और bottom half wood का है, तो किस side पे होगा center of mass? ऊपर की तरफ. The center of mass will shift towards the side that has more mass. Okay, in the same way, अगर section A, अगर पहले दूसरे section के ज़्यादा marks आ गए mid term के आपके थोड़े आए, तो किस तरफ shift हो जाएगा? Okay, anyway. So you have नहीं आपकी तरफ नहीं shift होता unfortunately, but anyway, okay. Okay, so but if it's uniformly distributed, the center of mass will be slam bang in the middle. क्योंकि आप देखो अगर एक छोटे से एक पीस को लो इधर, उसका पोजीशन वेक्टर ये है. There is a cousin piece, okay, जो किसका ऑपोजिट पोजीशन वेक्टर है, with the same mass. इन दोनों को ऐड करोगे तो क्या आएगा? 0. इसका और इसका mass equal है. They have opposite position vectors. I should stop asking these questions with answer 0, okay? वो default ही मान गया, okay? Okay, but anyway, you add these two, you'll get 0. M1 times this position vector plus M1 times this position vector gives you 0. Similarly, आप ये छोटा सा piece ले लो, इसका cousin इधर ढूंढ लो. you'll always find one particle and you can pair it with another particle with exactly the opposite position vector. You can chop up this sum into sum over pairs. और हर पेयर का सम क्या होगा? 0. So you just get 0 plus 0 plus 0 plus 0 plus 0. देखो एक से ज़्यादा 0 आ गया. Okay. So you just have overall 0. Okay. Another example. दो equal masses हैं, point particles, m1, m2. Let's just treat them as arbitrary right now. Okay. Find out the center of mass of these two point particles. Arbitrary रखे हुए हैं अभी. Okay. So the first thing that you do is set up some coordinate system. Because to actually do this, to calculate this, of course, you need to write down कि Ri क्या है. And Ri, of course, are the position vectors of these particles. Those position vectors depend on your coordinate system. So the first thing that you do in order to calculate the center of mass is to set up your coordinate system. Okay. Generally set it up in a smart way. There are two ways in which you can simplify your life. One way is कि इस तरह set करो कि at least one of the position vectors becomes 0. The other way is अगर आपके पास कोई object है, set the origin of your coordinate system at the point of symmetry. जिस तरह अभी मैंने rectangular sheet के साथ किया था. I could set up the origin of my coordinate system at the middle of the rectangular sheet and then I immediately argue कि भाई जितना position vector एक है उतना ही दूसरा आपको opposite भी मिल जाएगा आपको. Okay. So anyway, in this case I say कि भाई okay, let me align the x-axis along the line joining the two particles. And let me place the origin of my coordinate system at one of the particles. ये मैंने एक तीर से दो शिकार किए हैं इस तरह. The position vector of this particle becomes 0. So you simplified your life. And the position vector of this particle becomes quite simple because the position vector of this particle has only an x component, no y component. That's why I oriented my x-axis along the line joining the two particles. So that the position vector of both particles, the y component for both particles is 0. Because both particles then lie along the x-axis. Okay? And the y and the x coordinate for only this particle is non-zero. For this particle, the x coordinate is 0. Okay. Now, before I go on, I must highlight that this actually stands for three equations. You have x coordinate of the center of mass equals क्या? Capital X is the x coordinate of capital R, capital Y is the y coordinate of capital R. So you can then write down R1. If 2D में कर रहा हूँ, it's exactly the same calculation in 3D. And so on and so forth. You plug these in over here and you find that you can write down that capital X equals mᵢaᵢ over capital M. Of course. अगर position vector ये इस तरह है तो x coordinate of capital R should only depend on the x coordinates of all the particles. The y coordinate of capital R only depends on the y coordinates of all the particles and so on and so forth. Okay. Okay, so capital X in this case, capital Y क्या होगा इस case में? 0 because the y coordinates of both particles is 0. Yes, thank you. Okay. So this is equal to m1 0 plus m2 नहीं 0 नहीं. If this length is L, if the two particles are L away, तो इधर क्या लिखूंगा मैं? So capital X will simply be equal to m2 divided by m1 plus m2 times L. In other words, what I've shown is that the center of mass of two particles, first of all, lies along the line joining the two particles, as it's somewhere in between the two particles. So for example, m2, this is a number, ये जो brackets में number है, this is a number smaller than 1. So capital X is a number smaller than L, bigger than 0, but smaller than L. So it's somewhere between, somewhere along this line, somewhere over here. Of course, the actual position depends on m1 and m2. Okay. Suppose कि दोनों m1 और m2 equal हैं. Okay, so this is equal. If they are equal, I just say m1 equals m2 equals m. आपका क्या intuition क्या बताता है? Center of mass किधर होगा? बीच में. Okay, so let's check this. Okay, this is equal to m over 2m times L. M और m कट गया and you just get L over 2. बीच में. Okay. If m1 is much bigger than m2, we write that as m1 much bigger than m2. 2 greater than signs mean that it's much bigger. आपका center of mass किधर आप expect करते हो? m1 के बिल्कुल साथ ही होगा, because the center of mass will be dominated by m1. So let's see कि ये आता है या नहीं आता. फिर आपका आएगा कि capital X equals to m1 is much bigger than m2, and therefore you can write down that m2 बहुत छोटा है, so you can have m2 over okay. Now there are two ways to do this. एक तो तरीका ये कि सर आप कहो कि सर जी m2 बहुत छोटा है लिहाजा इसको मैं गोली मारता हूँ और ये m2 over m1 एक नंबर बहुत छोटा देगा. हाँ सेंटर ऑफ मास इन 2 पॉइंट पार्टिकल्स का कौन सा स्मॉल आर कैपिटल आर? ये तो इधर से तो ये आ गया ना. So the x coordinate of the center of mass equals the mass of the particles multiplied by the x coordinates, sum it up, divided by the total mass. ठीक है. और फिर अब मैंने एक्सिस इस तरह ओरिएंट किया है कि दोनों पार्टिकल्स का y कोऑर्डिनेट 0 होता है, तो कैपिटल Y क्या होगा? 0, because m1 y1 plus m2 y2 will just give you 0. So you're just interested in the x coordinate of your center of mass. X coordinate का center of mass in general ये आ गया है. Now the actual value depends on कि m1 और m2 हैं क्या. अगर m1 और m2 equal and the center of mass is right in the middle, if m1 is much bigger than m2, which is what I'm doing now, you can straight away argue कि ये m1 plus m2 is approximately equal to. आप तो L'Hopital rule वगैरह लगाते रहते हो. Now is your time to shine. Okay, m1 plus m2 is approximately equal to, if m1 is much bigger than m2, what is m1 plus m2 approximately equal to? Just m1. जैसे ये 1000 kg है, this is 1 kg, this is approximately 1000 kg. और ये क्या होगा? This is a small number relative compared to m1. As in other words, m2 over m1 is a small number. If m1 is much bigger than m2, then m2 over m1 is a small number, and therefore this is a number approximately equal to 0. And therefore the center of mass is where? Near your origin. आपके origin के बिल्कुल साथ ही है center of mass. और यही तो आप expect करते थे. If m1 is much bigger than m2, the center of mass should be very near, should be very close to m1. Another way to see this is, a more systematic way of seeing this is, दोनों साइडों को न्यूमरेटर डिनोमिनेटर को किससे डिवाइड कर दो? m1 से, राइट? और अगर ये ट्रू है, व्हाट इज m2 ओवर m1? A very small number, a very small number divided by approximately 1. 1 plus a very small number is approximately 1. So you get a very small number divided by 1, which gives you a very small number, which is approximately, then this is approximately 0.
Three particles with uneven mass, तो उनके masses same नहीं.
वो करेंगे. अभी दो के लिए तो कर देंगे. If m2 is much bigger than m1, फिर क्या आएगा? फिर the center of mass should be close to over here, as in capital X should be close to L. Let's see that. Okay, कि वाकई आता है नहीं आता. So you have capital X equals m2 over m1 plus m2, and m2 is now much bigger than m1. So as in m1 over m2 is approximately थैंक यू। सो दोनों न्यूमरेटर डिनोमिनेटर को किस चीज से डिवाइड करूं? नहीं नहीं, अस्तगफिरुल्लाह, 0 से डिवाइड करो न्यूमरेटर को भी डिनोमिनेटर को भी। आई मीन एक गुनाह किया और फिर दूसरी दफा भी गुनाह करने चले हो। Okay, so divide both numerator and denominator by m2 ताकि ये देखा आप ये चीज इस्तेमाल कर सको। m2 divided by m2 will be equal to 1। या ये वही है कि ये आपके पास x square over x है और मैं कहूँ कि लिमिट निकालो when x approaches 0। सो न्यूमरेटर को भी डिवाइड कर दें x से, डिनोमिनेटर को भी x से डिवाइड कर दें, फिर हम लिमिट देख लेते हैं। याद आया? नहीं याद आया क्योंकि आपने किताब को भूल गया। ओके, एनीवे ओके। So this thing gives you m1 over m2 plus 1 if you divide both the numerator and denominator by m2। और ये किसके बराबर है? Approximately 0, so you just get 1 divided by 1 और ये बाहर l है, so this is approximately equal to, okay, so the center of mass when particle 2 is much more massive than particle 1 is close to capital L, okay, is close to particle 2, okay। अच्छा, अब एक और एग्जांपल करते हैं। You have a thin rod, uniform rod for simplicity, okay, and I ask इसकी length L है, and I ask you इसका center of mass किधर है? यूनिफॉर्म है। So of course आप कहोगे दरमियान में। But of course, just to get familiarity with, just to get comfortable with this, कि capital R ये, let me show you कि this also follows from, के दरमियान नहीं आएगी, this also follows from this. If you use this, you do get that the center of mass is slam bang in the middle. Okay. Again, to use this, you first of all have to set up the origin. अब मैं क्यों अपनी जिंदगी आसान बनाऊं, थोड़ी सी मुश्किल बना लेते हैं, ओके, जस्ट टू शो यू के इट डजंट मैटर वेयर यू प्लेस द ओरिजिन ऑफ योर कोऑर्डिनेट सिस्टम। मैं कोऑर्डिनेट सिस्टम इस तरह सेट कर देता हूं। दिस इज माय एक्स एक्सिस, दिस इज माय वाई एक्सिस। ऑफ कोर्स कैपिटल वाई इस केस में क्या होगा? 0, ओके। पतली सी रॉड है, वो वाई कोऑर्डिनेट है ही कोई नहीं एसेंशियली, ओके। आई एम ओनली रियली इंटरेस्टेड इन कैपिटल एक्स, सो कैपिटल एक्स आई राइट एज अब ऑफ कोर्स आप कहोगे सर खुदा का खौफ करें, how am I supposed to do this sum? This rod is comprised of billions and billions and billions of atoms. इतने ज्यादा एटम्स के ऊपर मैं कैसे सम करूं? ये नहीं, सिर्फ एंड्स तो नहीं ना कंसीडर कर रहे हैं, दरमियान वाले भी कंसीडर कर रहे हैं। सो व्हाट यू डू इज, जिस तरह आप पतले पतले रेक्टेंगल्स का एरिया सम करते थे, essentially you convert this sum to an integral. How do you do that? Well, exactly what you do when you calculate an area. इसको छोटा सा एक पीस कंसीडर कर लो। इस पीस का मैं मैस कहता हूं कि दिस इज इक्वल टू डेल्टा एम आई। इस छोटे से डेल्टा मैं इसलिए कह रहा हूं बिकॉज इसका मैस बहुत छोटा होगा, इसकी पोजीशन छोटी नहीं होगी, इसकी पोजीशन ये है, दिस इज द पोजीशन ऑफ दिस पीस एक्स आई। xi is the position of is the x coordinate of the ith piece. इसका mass बहुत छोटा है because I've considered a very thin piece. इसकी कोई thickness भी है, इस piece की thickness है delta xi. Right? The change in the value of x that occurs over this piece is the thickness of this piece, delta xi. Okay? So then I can write this thing as sum over I over all the pieces. डेल्टा एम आई, हर पीस का मैस है डेल्टा एम आई टाइम्स द पोजीशन ऑफ ईच पीस विच इज एक्स आई डिवाइडेड बाय एम, एंड आई हैव टू ऐड दिस अप ओवर ऑल द पीसेस, जितने भी पीस हैं। इफ आई चॉप दिस अप इनटू n pieces, that's what I get. I'll get a more and more accurate answer the more I chop it up into smaller and smaller pieces. In the limit where I chop this up into infinitely small pieces, इस सम को क्या होगा? नहीं, 0 नहीं होगा, नहीं, दिस विल बिकम एन इंटीग्रल। याद आया? अस्तगफिरुल्लाह। द स्मॉलर एज यू मेक डेल्टा एक्स साइज स्मॉलर एंड स्मॉलर, इसको क्या होता है इस सम को? Each time in this sum becomes smaller and smaller as delta xi becomes smaller and smaller, but the number of terms becomes infinitely big. your sum consists of infinitely many terms, each one of them infinitely small. In exactly the same way over here, जैसे जैसे ज्यादा पीसेस में चॉप अप करोगे, हर छोटा पीस का मास छोटा होता जाएगा, लेकिन नंबर ऑफ टर्म्स इन दिस सम विल आल्सो गो अप. सो दिस विल बी इक्वल टू, इसको इंटीग्रल फॉर्म में कैसे लिखूंगा? x dm over capital M. This is the integral of the position over the mass of the rod, or integral of the position over all the particles within the rod. और ये limits क्या होंगे? Well, the limits depend on, you have to integrate over the whole rod. इस केस में yes. Okay. Okay, so let's do this integral now. सबसे पहले to do this integral, जिस तरह आप कहते हो या ये कर्व का एरिया कैसे निकालते हो? y dx. This is how you calculate the area in the curve. इस इंटीग्रल को करने के लिए आपको क्या चाहिए होता है? y as a function of x. So to actually do this integral, you either need m as a function of x, कि आप dm को लिख सको in terms of dx, या आपको चाहिए x as a function of m. Either one will do. Okay, so this integral, I say, okay, dm है क्या? dm is the mass of this little piece, which is equal to, अगर ये यूनिफॉर्म रॉड है, कैन आई राइट दिस इन टर्म्स ऑफ dx? यूनिफॉर्म रॉड है, इस छोटे से पीस का जिसकी थिकनेस dx है, इस छोटे से पीस का मास क्या होगा? अस्तगफिरुल्लाह, ये तो इंफिनिटी आ गया है, dx तो बहुत छोटा है, m over l times dx है. दिस इज ए यूनिफॉर्म रॉड. अगर टोटल लेंथ ऑफ द रॉड का मास टोटल m है, तो छोटी सी थिकनेस की पी जो dx है उसका मास कितना होगा? अगर 12 अंडों की कीमत 200 रुपए, 400 रुपए है, आई मीन आई हैव टू कीप अप विद द टाइम्स, ओके, 400 रुपए अगर दर्जन अंडों की कीमत है, तो 2 अंडों की क्या कीमत होगी? यू फाइंड आउट द प्राइस पर यूनिट एग मल्टीप्लाइड विद द नंबर ऑफ एग्स, mass per unit length multiplied by the length that you are dealing with. So this becomes x m over l times dx. और अब आपने इंटीग्रेट करना है पूरे रॉड के ऊपर, ऑफ कोर्स बाहर 1 over m भी था. अब पूरी रॉड के ऊपर इंटीग्रेट करने का मतलब यू इंटीग्रेटिंग ओवर x नाउ. द लेफ्ट एंड ऑफ द रॉड इज एट x is equal to 0, the right end of the rod is at, और ये इंटीग्रल तो देख के आपके मुंह में पानी भर आया होगा, ऑफ कोर्स, ओके. दिस इज द ओनली थिंग दैट यू अंडरस्टूड फ्रॉम टुडेज लेक्चर एनीवे. तो m over l जो है वो इंटीग्रल से बाहर चला जाता है, m एंड यू हैव 1 over m, सॉरी 1 over m over l, और फिर आपका आ गया x dx. x dx का इंटीग्रल क्या देगा आपको? x square over 2, पुट इन द लिमिट्स यू विल गेट l square over 2. ये m और m कट गया, l, और ये क्या आ गया? l over 2. और आपका सेंटर ऑफ मास किधर आएगा? दरमियान में.